Good evening and welcome to the session number 11 from the playlist of Assertion and Reasoning. The topic is the acceleration of a charged particle in an external electric field. So based on this topic, I have framed one question for this session. And this question consists of two parts. The first part is the assertion and the second part is the reasoning. Reasoning is a statement which supports the assertion. And based on these two statements, we have four options here and we have to find the correct option. So the assertion here is a deuteron and an alpha particle are placed in an electric field. The acceleration achieved by both the particles will be equal. So this is the assertion. Reasoning is forces on both the particles will be the same. Now deuteron is basically the nucleus of a heavy hydrogen, and the mass of the deuteron, let us say md, this is approximately equal to 2 atomic mass unit, and the charge on the deuteron is equal to plus E. So this is basically a positively charged particle. Now let us come to the alpha particle. Now the mass of the alpha particle, let us say this is m alpha, this is equal to 4 atomic mass unit. Alpha particle is basically a helium nucleus which consists of 2 protons and 2 neutrons. And the charge on the alpha particle, this is equal to plus 2e. So both these two particles are positively charged. Now when they are placed in an external electric field, then the electrostatic force on the deuteron, let us say Fd, this will be equal to the electrostatic force on a charged particle when placed in an external electric field is equal to Q into E. So here the electrostatic force on the deuteron when it is placed in an external electric field will be equal to, here I have depicted this electrostatic force as Fd. Fd is the electrostatic force on the deuteron when it is placed in an external electric field, and this will be equal to E into, let us consider the intensity of the electric field as capital E. So this will be equal to small e multiplied by capital E, and this will be equal to mass into acceleration. Or let us consider the mass of the deuteron equal to small m. So and AD here is the acceleration of the deuteron. So the acceleration of the deuteron will be equal to small e multiplied by capital E divided by m. And now let us consider this alpha particle. So when an alpha particle is placed in an external electric field, then the electrostatic force on it will be equal to, that is F alpha is the electrostatic force on the alpha particle when it is placed in an external electric field. So this will be equal to, now here the charge on the alpha particle is equal to 2e, and the intensity of the electrical field has been taken as capital E. So this is equal to 2 small e multiplied by capital E, and this will be equal to the mass of the alpha particle. Now the mass of the alpha particle is 2 times the mass of the deuteron. So if the mass of the deuteron has been taken as small m, then the mass of the alpha particle will be equal to 2m into the acceleration of the alpha particle. So from here again, this 2 and 2 will get cancelled out. So the acceleration of the alpha particle will be equal to small e multiplied by capital E divided by small m. So from here we can see that the acceleration of the deuteron and the acceleration of the alpha particle are equal. So the assertion is correct. Now here in the reasoning we have been given the statement which says that the forces on both the particles will be the same. So here the electrostatic force on the deuteron is equal to small e multiplied by capital E, whereas the electrostatic force on the alpha particle is equal to 2 into small e into capital E. So here the electrostatic force on the alpha particle is just double the value of the electrostatic force on the deuteron. So the reasoning is not correct. So from these four options which we have, the option C is correct because here In the C option, A is correct, that is assertion is correct, and the reasoning is incorrect. So the correct option here is C. So in the next session, I will be coming up with a different type of a question from the same chapter of electric charges and fields. So till then, have a nice day. Bye.